Hello, geometry. This is 11.3, Areas of Polygons. This should be something new. We'll have some new vocab in here and a little bit pulling in from stuff we've done before, especially with triangles and circles and polygons that are inscribed in circles. So, jumping right in, the question is, how can you find the area of a regular polygon? So regular, remember that means all the sides are the same length. All the sides are the same length. All angles are congruent. So it's congruent sides and congruent angles. Congruent sides and congruent angles. Okay, the center of a polygon, so if we have a pentagon, I've already drawn on another page. It does not look this good. I did not do it too precisely. But if you would circumscribe a circle, so if you put a circle on the outside of the polygon that goes through each of the vertices, that'd be a circumscribed circle. The center of that circle is referred to as the center of the polygon. Okay, again, these are regular polygons, so squares, not rectangles, equilateral triangles, pentagons, hexagons that are all regular. Okay, so that'd be the center of the circle. The distance from the center to any side of a regular polygon, that is called the apothem. Okay, the apothem of a regular polygon. So that would be this here, this distance from the center to the side. That distance right there, which is going to form a right angle. This is also going to form an isosceles triangle. It can be an equilateral, but it doesn't have to be. Okay, so what we also have here is an isosceles triangle, which means if you have an isosceles triangle and this is 90 degrees, that this is going to bisect the side. So the apothem bisects the side of the polygon and the central angle. Okay, so this apothem is going to bisect, it's going to go right through here, and it's going to bisect this side of the polygon. So if the whole length of the side is 10, then it would be 5 and 5. And it's also going to bisect this angle in here. So we can figure that out, and we're going to see that here in a little bit. We have a pentagon, so we have 5 sides. That means each of these have to be the same. So if I take 360 degrees for the whole circle and divide by 5, I get 72 degrees. Okay, that means this big angle here is 72. So 72, 72, 72, 72, 72. If you draw the apothem, it's going to bisect that and make it into a 36-degree angle. Okay, and you can figure that. That's going to be kind of the first part of what you're doing. Okay, so 36 and 36. Okay. Okay. So that's the terminology. The apothem is new. The apothem does a lot of bisecting of the central angle and the side. This right here, okay, if you're looking at this, this is called the radius of the polygon. And the radius goes to a vertex. The distance from the center to a vertex. That is different than the apothem. The apothem is going to go to a flat side and make a 90-degree angle. The radius is going to go to the corner of the vertex. So the radius, there's 5 radii here. They're going to go to the corner and they're going to form a central angle for the circumscribed circle. Okay, so a lot of that terminology shows up again here on page 326. Yeah, there's my pentagon. Okay, so if I would circumscribe a circle, the center of that circle would be the center of my polygon. Okay, so the center of the regular polygon, that is the center of the circumscribed circle. Center of the circumscribed circle. Okay, the radius of the polygon goes from here to a vertex. So the radius goes from the center to a vertex. It's the distance. The apothem goes from the center to a side, and it's going to form a 90-degree angle, and it bisects the side and central angle. Okay, so the apothem can go right here. 90-degree angle, bisects that, and that is also going to bisect that and that. Okay, so the apothem goes to the side, the radius goes to a vertex. The central angle of a regular polygon, this is the angle formed by consecutive radii. The angle formed by consecutive radii. Okay, so two radiuses that are right next to each other, that would be your central angle right there. The central angle would be right there. There would be 5 central angles. Okay, so the central angle, there's a formula for that. That's equal to 360 degrees divided by the number of sides. And later on, this is going to take the variable n. N is going to be the number of sides. So the central angle is 360 divided by the number of sides, or the number of sides, which is n, would equal 360 degrees divided by the central angle. Okay, you can switch those two around there as a proportion. Okay, those two formulas will be helpful as well. Okay, unique formula, area of a rhombus or a kite. Now remember, a kite has to have 2 sets of consecutive sides, but they're not opposite of each other unless it's a rhombus. This is a unique formula you can use for the diagonals. Okay, the diagonals connect opposite vertices, and it's just 1/2 of the product of the diagonals. The area of a rhombus or kite with diagonals D1 and D2 is 1/2 the product of the diagonals. So if I have a kite here with diagonals length 8 and 12, my area would be 1/2 times 8 times 12, and that would be 48 square inches. Let's say these are inches. Okay? So you just multiply the diagonals together, divide it by 2, or multiply it by 1/2, and you get your area of the rhombus or kite. Those are easy. Quick review of this, which will come into play, especially the 30, 60, 90. If you have a 45, 45, 90, the hypotenuse is root 2 times as long. So remember, if you're going from here to here, you're multiplying by the square root of 2. You're going from here to here, you're dividing by the square root of 2. Same thing, a 30, 60, 90, which we'll see. X to 2x, you're multiplying by 2. X to this, you're multiplying by root 3. Find the longer leg. This is the longer leg opposite to 60. The shorter leg is opposite to 30. Here you're dividing by 2, and here you're dividing by the square root of 3. Okay. Hopefully you still have those notes. That comes around. Okay. Here's your formula for the area of a regular polygon. Area equals 1/2 A. A is the apothem. Okay, so A is the apothem right there, and the perimeter. So perimeter can be referred to as n times the side length. So that's where it comes here. N is the number of sides. The S is the length of one side. Now remember, this is of a regular polygon, not an irregular polygon. Okay, so if one side is S, all the sides have to be S in this case. So 1/2 apothem times the perimeter, or 1/2 apothem times the number of sides times the side length of one side. Okay, and we can manipulate those any way we want to try to figure it out. This one, we could say 2 times your area equals the apothem times perimeter. So your perimeter could equal 2 times your area divided by apothem. Notice the little a is the apothem, the big A is the area. Or you can go another direction. You could say the apothem equals 2 times your area divided by perimeter. Depending on what you're looking for, you can use algebra to figure out which variable it is. Okay. This one, let's say you want to find out how many sides does it have, and you know everything else. So 2 times A equals A times N times S. Answer. So if you want to solve for the number of sides, you have to take 2 times A divided by the quantity A times S, and you get your number of sides. Okay, exercise 1 and 2. Find the area of the kite or the rhombus. So here is a rhombus, And it appears that, I think this 10 inches is supposed to be this diagonal. 10 is up here. These two are bisecting each other at a 90-degree angle then, because it's a rhombus. So the area is 1/2 of diagonal 1 times diagonal 2. The diagonal goes clear across, so the area equals 1/2 times 20 times 14. So the whole length from here to here is 20 inches, and from left to right it would be 14 inches. Okay, you use the entire length, not just half of it. So area 1/2 20 times 14, that'd be 140 square inches. Okay, 140 square inches. This is a kite. These will not bisect each other. So it is a kite, not a rhombus. These will, so that's why we know it's a rhombus. This segment should be bisected, but not both of them. So from left to right, it looks like 5 plus 3 is 8. From top to bottom, we have a length of 4. So area equals 1/2 times 8 times 4. So area is going to be 16 square centimeters. Okay, getting to the polygons. Find the measure of a central angle of a regular polygon with 8 sides. So you have an octagon, and we have 8 sides. They want a central angle. So a central angle would be that measure right there. Now remember, how many central angles do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 central angles, which matches the number of sides. So a central angle equals 360 times the number of sides. This is a formula we had earlier. Okay. The central angle equals 360 divided by number of sides. So that's 360 divided by 8. I believe that's 45 degrees. Okay. So this would right here would be 45 degrees. Each of these around here, 45 degrees. Okay, the central angles of a regular polygon are 40. How many sides does it have? Isn't this nice? I give you the formulas right off the bat. Number of sides is 360 divided by the central angle. So the number of sides equals 360 divided by 40, which would be 9. It's a nonagon. Na-na-na-na, na-na-na-na, hey, nonagon. Okay. A regular pentagon. So we have 5 sides. So n equals 5 has a radius of 4 inches and a side length of 3 inches. So do my best to draw my pentagon. I have a radius of 4 inches and a side length of 3 inches. Find the apothem of the perimeter. I'm going to have to give you some more formulas here. I didn't get that down. Yes. Okay. So when you want the apothem is going to be right here. It's going to form a 90-degree angle. That's A, and that's going to give me 1.5. So you notice we have a right triangle here. The radius takes the position of the hypotenuse. Okay, and this is going to be half the side length. So you see the right triangle being formed here. We're going to use the Pythagorean theorem. So I know that a squared plus 1.5 squared has to equal 4 squared. So in this 1.5 came from its half of the side. So if I want a squared equals 4 squared minus 1.5 squared, and then you have to take the square root of that. So a is going to be the square root of 4 squared minus 1.5 squared. So if I put the other terminology in here, I know my apothem equals the square root of the radius squared minus 1/2 of the side squared. So the radius squared minus 1/2 of the side squared. That's what we have here. The radius is 4, and 1/2 of the side is 1.5. Okay. So I need the square root of 16 minus 1.5 squared, and we get about 3.71. The apothem is about 3.71, and we are in inches. That's how we find the apothem. Okay, it will not always be given to you. Find the area of the pentagon. So I have the radius, I have the number of sides, and I have the side length. So area equals, make sure I copy this down correctly. There it is. Area equals 1/2 A times P, or 1/2 A times N times S. So it's going to be 1/2 times A times N times S. That's what I'm going to use. So that's 1/2 times the apothem, that's 3.71, times N is the number of sides, that's 5, times S, the side length, that's 3. Okay. Now, I would take this last answer. If at all possible, I would keep that last answer. That's my apothem. And I'll just say, okay, I'm going to take that answer times 1/2 times 5 times 3. The less rounding you do, the more accurate your answer is going to be. Okay, and that gives me 27.81. So the area is about 27.81 square inches. Okay. So here, a regular hexagon has an apothem of 10 units. That's all they've given us. Find the radius of the hexagon and the length of one side. Hexagons are going to fall underneath that 30, 60, 90 rule. Okay. So here's my center. So when you draw this, remember you have 6 central angles. So a central angle is 360 divided by 6, which is going to be 60. So this is 60 degrees. But when you draw your apothem, remember you cut that in half, so now this is going to be a 30-degree angle. Let's go down here. Here's my radii. I'm going to draw my apothem right here. And this is going to be 30 degrees, making this a 60-degree angle. You see the 30, 60, 90 that's being formed here. Okay, so if your apothem is 10 units, that is the longer side of your triangle. So if you want to find the short side of your triangle, about time for class. If you want to find the short, there it is, page 326. If you want to find the short side of your triangle, you have to take this divided by the square root of 3, right down here. We know the long side, we have to divide by the square root of 3. So this is going to become 10 divided by the square root of 3. Okay? Now the length of one side is going to be that times 2, so times 2 gives us 20 over the square root of 3. They may not like the square root of 3 on bottom. Remember, we take top and bottom times the square root of 3, and you get 20 root 3 over 3 when you're all said and done with that. So the length of one side would be 20 root 3 over 3. 20 over the square root of 3 might also be accepted. You can try that out. Okay. So this right here, this is going to be 10 over root 3. So if you take that times 2, that's going to be your radius. Okay? So here, you're going from here to your hypotenuse, which is times 2, x times 2. So 10 root 3 times 2, we know is going to be 20 root 3 over 3. It's going to be the same. If this is 60, then this is 60, and we know this is 60. This is an equilateral triangle. So a regular hexagon forms equilateral triangles, which means the radius and the sides are going to be the same. So the radius equals the side. Okay, so find the area of the hexagon. So area equals 1/2 times the apothem, which we know is 10, times the number of sides, which we know is 6, times the side of one length, which is 20 root 3 over 3, or 20 over the square root of 3. So we have 0.5 times 10 times 6 times 20 divided by, I'm just going to type it in like that. And we get 346.41 square units. We're just in units. Okay. I don't think we'll have any trig with what you need to do. Trig is definitely applicable to this. You're dealing with a lot with triangles, and there's right triangles that are formed with the apothems. You're starting off with some areas of kites. Area of the rhombuses, just 1/2 diagonal 1 times the diagonal 2. The next set of questions is just identifying what is the center. So what point is the center? Okay, what is the central angle that they're showing here? You're just identifying parts of the circle. Find the measure of the central angle with the regular polygon 10 sides. Use the formulas that I gave you. This is like questions 3 and 4. Okay, measures 3 and 4. Here we go. Find the measure of GJH. GJH, that's a central angle. GJK, that's half the central angle. KJG, okay, there's that right triangle. You have to find that half the central angle, and then you're going to find that one. Okay, now you get into the area of a regular polygon. Notice they're giving you the radius and a side length, so you have to find the apothem. We have a formula for that, use that. And a composite figure, and then a review of symmetry. So that is it. That's 10.3, or 11.3, sorry. 11.4, I think we're getting into three-dimensional figures, so I'll do my best to try to make those pop out on a two-dimensional surface and two-dimensional video. So I'll see you soon. Good luck. Let me know what questions you have, and hang in there. Hey, if you keep finishing strong, keep working. Okay, hopefully you're getting done early.